Welcome to video number 4. In this video we are going to still focus on special angles and extend the information a little bit. And our special angles this time would be using a Cartesian plane. So that's the focus. And this will allow us to check what 0 degree would look like, what 30 again would look like, what 45 degrees would look like, what 60 degrees, and what 90 degrees would look like. And secondly, we would extend the information to the nature of the Trig ratio. If theta is now between 0 and 360 degrees, which means we could therefore be looking at 180 degrees, 270 degrees, and 360 degrees. All right, 360 degrees. In order to make this very interesting, we would need to do a little bit of some construction. So let's go and do a few construction. Okay, I will need first to create a Cartesian plane. All right, good. All right, so I have a Cartesian plane there. I would need a ruler. Basically, I would actually need two rulers. One for my x, all right, one for the x-axis there, all right, and one for the y. So we need to find a way to turn this ruler. Awesome. 90 degrees. Beautiful. Okay. Because I want to measure a few things. Lovely. So we have the x and the y. All right. To measure my angle, I'm going to need that. Okay. Let's just make this a bit smaller if we can. No, I don't want it to turn. Okay, let me bring in a new one. There we go. And let's make it smaller. Seems to want to turn. Just going to make it, it's fine. If it doesn't want to become small, we would use it like that. Alright, just at the center there as well. Okay, almost perfect. Almost perfect. So, let's create a circle with a 2-unit radius. So I have my circle there, and I'm creating a circle. Can you see where my circle is? It's a 2-unit radius. Lovely there. That's 2. Good. That tells me that my circle round, equidistant from the center, will be 2 centimeters. Now, let's start creating our angles. First, I'll use the red one. I want to create my 30 degrees, so I'm stopping right there, okay, and creating that angle. Let's see where this would lead us. That's about 1 point something that we're not sure, but let's see where this would lead us here. Oh, that brings us to 1. So our y value there is 1. Okay. Before we move all of this away, I'm just going to quickly draw and then we'll read together. So don't get confused. I used red for the 30. I'm going to use a different color for 45. Let's go check what the 45 would be. All right, so that's my 45 degrees there. Okay, I can then do this here. Let me just draw rightly from the center. 45. So it's not going to be perfect, but it will just give us an estimate. All right, and then I have that there, and then I have this there. Okay, just an estimate. We'll be able to see what that would be. That is about giving us about 1 point. That's 1 point. This is 1. We have 1.5. It's about 1.4 somewhere there. 1.4. All right. We would see how to get the accurate measurement, and then we can try the 60. Let's use a green one for the 60. Or something lime. 60. Okay. think we can have something a bit more perfect. 60. All right. And then we trace it down. That actually almost comes down to 1. But let's see. I think the 60 is just a bit tricky now. All right. So I've got that. Okay, that looks more lovely. I want something very straight. Okay, and then we have that there. The vertical line seems to not fall in place. Okay, I'm just going to quickly undo, and undo the 60. I see a little bit of adjustment that needs to be done. All right. I'm just trying to get, I have an expectation. Alright, that seems fair enough. Would work with what we are expecting. Alright, so we have 30, 45 and 60. Now I'm going to write my x values and the y values. Alright, let's deal with the 30 first. Do you notice the 30 actually, my y value on the 30 is 1. Okay, I don't think I need this anymore. Thank you, protractor. Let's keep it in the safe now before somebody disappears with it in class. Good. Okay, I think I have my clearer measurements now. So we're dealing with the 30, so I'm going to maintain a red for 30. We see here my y value is 1. All right, my y value there is 1. Mind you, my radius, which is the hypotenuse, remains as 2 because we used a radius of 2 units. Okay, so on the side, let me try to create something here. So we have a triangle that looks like this. It's a right angle triangle. All right, but it's on the other side, so I'm going to flip this so it looks more like this, and the angle here is actually 30. All right, we know this as 2, and the height from here to from there to where my red circle there is 1. Now this is my 2. Now the question is, what is going to be our x value? I hope it makes sense. Remember, the circle has a radius of 2, and that's my radius there. That's r. Now this is the vertical, which is called our y, and this is the horizontal, which is what? X. We can then use our Pythagoras theorem to get the value of x. R squared will be equal to y squared plus, so my r there is 2, my y is 1 squared plus what? X squared. If I bring that over, it becomes 4 minus 1, which is what? 3. 3 equals to x squared, and my x therefore is root 3. Okay, so my x value on the 30 is root 3, and my y value is 1. Remember how we write coordinates? X and y. Beautiful stuff. So I'm using red for 30. All right, so my red is 30 degrees. Don't forget that this is 2. That's the radius. My r is 2. Let's go deal with the 45. Let's deal with the 45. All right, let's deal with the 45. What do we know? Okay, the 45, I'm going to clean this for space. Now, if this angle is 45 and this maintains 2, because these angles are now equal, it means this y and this x would actually be equal lengths. All right, so if I have 2 squared there, since x equals to y, because of the angles being equal right now, we talk about an isosceles triangle. All right. Angles opposite equal sides. So because it's 45, 45, this side therefore is equal to that side. So x equals to what? Y, which means I can come here and write x squared plus x squared. Remember, because x equals to y. An isosceles triangle, the two base triangles are equal and the two opposite sides are also equal. So what do I have? 4 equals to 2x squared. Now divide both sides by 2. X squared equals to what? 2. What is x? Square root of 2. And because x equals to y, y is also square root of what? 2. So we have our coordinates. It's a blue this time around. So we have square root of 2 and square root of 2. So I have blue as my 45 degrees. Don't forget again, the whole radius there is 2. Okay. If we therefore go and deal with our 60 degrees, let's clean this again. This is just beautiful math. 60 degrees. So we have this angle as what? 60. Remember, it's a radius there, which is 2. That's my r. If you check the x, actually the x measured correctly would be resting on 1. So I don't know my y. So what again do I have here? 2 squared. I do not know the y, so let's go find the y. Plus 1 squared. And 1 squared will give us 1. So you have 4 minus 1, which is what? 3, equals to y squared. And y is the square root of what? 3. Green. So my x coordinate is 1. My y coordinate is square root of 3. Remember again, that is 2. So we have green as what? 60 degrees. Okay, I'm going to lose my rulers just now. Don't need them anymore. Okay. Now remember that the length here of the radius is 2. And this is my x axis and that's my y. So what is the coordinate of this point? Remember, under analytical, y equals to 0 here. So my x is 2 and my y is what? 0. Now, what about this point? This is still 2 vertically, still 2. So my x, and here on the y, x equals to 0. So what's the coordinate here? X is 0 and y is what? 2. Lovely. So we have our Cartesian plane all set for analysis. I'm just going to use this triangle on the side. Now that I have my 30 degrees, let's start from there. This is the x, that's the y, and the radius. What is sine? Remember, so, katua, so. Sine here is opposite over what? Hypotenuse. So is y over what? R. Okay, we need to keep that because we are going to need that along the way. So I'm going to come here and write it. My sine is y over r. What about my cos? If you're lost here, you need to go back to the first video and check again. What is cos? Adjacent. So if this is opposite, hypotenuse and adjacent. So my cos is simply going to be x over what? R. Adjacent over hypotenuse. So let's come here and write it there. Cos is x over r. What about tan, which is TOA? Y over x. Lovely. We have all our trig ratio now set. Alright, having done all this, we can then decide, or we can find the value of all our angles. So I'm going to clean the side of the board and work with this. Good. Now, what is sine? Let's start from sine. We go through 30, we go through to 60, or no, we go through to 45, we go through to 60, now we go through to 90, and then 0. Alright, sine, sine, sine. Now remember what sine is. Sine is y value over what? X over r, y over r. So remember, we're dealing with the y value over r. And in this case, our r is just what? 2. Alright, let's go to 30. Remember, we're dealing with the red one. What is my y value? It's 1. Remember, this is x, and that's y. So 1 over, what is my r value? 2, the radius. And if you remember in the third video, that's what we got. Sine 45. Again, sine is y over r. What is my y? Root 2. What's my radius? Over 2. Our rationalized value. What about sine 60? Again, it is y. Alright, we're dealing with the green one now. Y, which is root 3. So we have root 3 over 2. Lovely. What about 90? 90 degrees is now here. It is going to be my y value over the r value. What is my y value here? Because that's sine 90 there. Is 2 over 2. And that equals to what? 1. What is sine 0? Sine 0 is right on the x. Because there's no angle there. Alright, so line on the x, that's my angle. 0. Again, it's y over r. What's my y value? 0. So 0 over 2, and that should give us what? 0. Let's check our answers quickly. I'm not going to check 30, 45, and 60 because we've done that before. What is sine 90? 1. There we go. What is sine 0? 0. There we go. So using our Cartesian plane, we can get our special angles as well. Alright, so that is the sine. Let's go for the cos. And you can quickly try that on your own, pause the video, and work through. Alright, so we're going to look at cos 30 in the same order. Cos 60. Not 60. Cos 45. Cos 60. Cos 90. And cos what? 0. By the way, what is cos? X over r. Remember, our r is still what? 2. Now 30. X. What's my x value? The red one is the 30, remember? Root 3. So we have root 3 over 2. What about cos 45? My x value? Root 2 over r value, which is what? 2. What is my cos 60? My r value is 1 over what? 2. That we did a while ago in the third video. 90 would be x over r. What is my x value for 90? It's 0. So we have 0 over, and what's my r? 2. And that should give me what? A 0. What about cos 0? Remember, cos 0 is back on the x-axis there. And I have 2 there. So I have 2 over my radius, which is 2. 2 over 2, and that should be equal to what? 1. Can we check again quickly? Alright, so we're just going straight for cos 90 degrees, and that gives me a 0, which is correct. And cos 0, and that gives me what? A 1, which is also correct. Alright, so cos is x over r. Let's quickly check out our 10 value. 30, 45, 60, 90, and 0. What is 10, by the way? Y over x. Alright. So let's go check. 30, the red one. Y over x. 1 over root 3. What about 45? Again, it's y over x. Root 2 over root 2. 1. What about 60? Y over x. What about 90? Y over x. And 2 divided by 0 is undefined. We will check on the calculator just now. What about 0? Y over x. Okay, let's go check on our calculator quickly. We're checking for tan 90. You see, it gives us an error, which means it's undefined. 2 divided by 0 is undefined. What about tan 0? Tan 0 is 0. Alright, so that's our special angles on the Cartesian plane, working through 30, 45, 60, 90, and 0, using our Cartesian plane to work through all of that. Alright, having looked at this now, let's try to move around our quadrant and see what will happen with the value of sine, cos, and tan in each of the quadrants. So I'm going to move to a new page quickly and just create a new quadrant there. Okay, and let's just create a very fresh, a new circle. Alright. Okay, we have that circle there. Alright, we have that circle. Quickly, this video is not supposed to be too long, so that we enjoy the video. Alright, I'm just going to try to reduce that and try to increase that so that we have okay. Alright, let me just delete that and draw a fresh one so that it looks like a good. Okay, we have that. Now remember, do not forget what our sine is. Our sine theta is, remember what we had? Y over r. Our cos theta is x over r, and our tan theta is y over x in each of these quadrants. Now we are going to move anti-clockwise. That's how we name our quadrants in maths. Okay, so let's quickly look at the first quadrant. In the first quadrant, do you notice, if I were to go back to my first quadrant here, do you notice that all these values are actually positive? My x and y values are all positive. Okay, so in my first quadrant, x, y, and r are all what? Positive. And in the first quadrant, my angle is actually lesser than what? 90 degrees. So this is what my first quadrant will look like. Alright, so we have that. X, y, and r are all positive. So if x, y, and r are all positive, positive divided by positive will be positive. Positive divided by positive there, all are positive. What that simply means is my sine, my cos, and my tan will all be positive if my angle is between 0 and 90 degrees, quadrant number 1. So here we say all are positive. Sine, cos, and tan are all positive because my X, Y, and R are all positive. Alright. What if I move to a new quadrant, the second quadrant? Okay, let me label this using red. Our first what? Quadrant. What will happen in my second quadrant? Now, if I move to the second quadrant, I am actually going beyond what? 90 degrees. Alright. So, in my second quadrant, so I'm going to write everything for the second here. My theta now is between 90 degrees and what? 180 degrees, because it's a straight line. Alright. And another way of writing that is to say theta is an element of what? 90, right? And what? 180 degrees. Okay. That is my second quadrant. So all my angles are greater than 90 but less than 180. Okay. Let's have that. So where is my angle? My angle is there. That's my theta. Greater than. Now, what do we notice in the second quadrant? I am still dealing with a positive y value here in my second quadrant. I am dealing with a positive y value. Remember your Cartesian plane. So y is positive. What about the x? Now I am moving to the negative value of x. So my x is what? Negative. R will always be positive. The radius of the circle. You cannot have a negative radius. Then that means the circle doesn't exist. So R will always be positive. Okay. Now let's go and check what's going to happen here. My y is positive, so I'm going to have positive over positive, and that will be what? A positive value. What about x? Negative divided by positive, which will be what? Negative. Right? What about tan? My y is what? Positive, and my x is what? Negative, and that will give me what? Negative. Take note of this. The only trig ratio that is positive there is sine. So I'm going to come here and say S is positive. The others are negative. And I want us to try quickly. Let's use our calculator for speed. What is sine? I'm just going to pick a number between 90 and 180. And you can try that in your calculator. What is the sine 100? Now, do you see it gives me a positive answer because it said sine is positive. What about cos 100? Oh, negative. Tan 100? Negative. In fact, let's go as far as sine 170. Still lesser than 180, right? And greater than 90. Positive. Cos 170. Negative. Tan 170. Negative. So in the second quadrant, sine is the only one that is positive. All others are negative. Okay, I hope that makes sense. Let's try the third quadrant. Almost looks like a pizza now. The third quadrant. Now I am moving to angles greater than 180. So my third quadrant is this. Oh no, sorry. My third quadrant is this. Now I am moving to angles greater than 180, but less than what? 270 degrees. Alright? Which I can also write as theta there, belonging to set of between 180 and 270 degrees. Okay, let's see. I'm going to claim the side again. I'm sure now you can predict what I am going to do. This is y over x. Let's make it black for uniformity. Y over x. Alright. In this third quadrant, I am still with my negative x. Remember, It falls here. By the way, my y is also negative, so it's negative x and negative y. Let's go write all the things down. My y is negative, my x is negative, but my r, like we said, the radius will always be positive. So let's check here quickly. What is sine? Negative over positive, which is going to be what? Negative. Cos? Negative over positive, which is also what? Negative. And tan? Negative over negative, which is what? Which means tan is positive in the third quadrant. So it seems like we're sharing the quadrants now. Alright, let's check with our calculator quickly. A number greater than 180 less than 270, 200 will be an example. Sine 200, what are we expecting? Drum roll, negative. Let's check. Yes, negative. Cos 200. Let's hope we're right. We're expecting a negative. Yes. Tan 200. Alright, thumbs up. Fingers crossed. Positive. Yes. Tan is positive in the third what? Quadrant. Alright. Let's go to the fourth one, and then we round up this session of the video. In the fourth quadrant, what are we looking at? My angle is now greater than what? 270, but less than 360. So which angle am I looking at? I'm moving beyond 90, moving beyond 180, moving beyond 270, and I'm here now. What do we know here? We are back with a positive x value and a negative y value. Alright. As before, let's clean all of that to help us deal with the signs. Okay, what is my angle restriction here? My angles are between 270 degrees and 360 degrees. And we can write that theta being an element there between 270 and 360 degrees. Okay. What do we know? Our x is positive, our y is negative, and our r is always what? Positive. Alright, sine. Y is negative, so negative over positive, sine is negative. X is what? Positive. And r is positive. Oh, this time around, cos now seems to take the place. Cos is positive. What about tan? Negative y, and our r, our x, is positive. Oh, so this time around, cos is negative. And this is the fourth what? Quadrant. Okay, let's check an angle. 300 will be fine. Sine 300. What are we expecting? Positive or negative answer? We're expecting a negative. Yes, negative. Alright, good. Cos 300, which is positive there. Alright, 0.5. And tan 300, what will that be? Negative. So we're perfectly correct. Cos is positive, which means if I then create a new page for clarity, this is what we came up with. We came up with this. Alright, this is what we are concluding at. Alright, here, okay, first quadrant, second quadrant, third, and the fourth, going anticlockwise. Here, theta is an element of angles between 0 and 90 degrees. Here, theta is an element of angles between 90 degrees and 180 degrees. Here, theta is an element of angles between 180 degrees and 270 degrees. Here, theta is an element of angles between 270 degrees and what? 360 degrees, which can also be written as 0. Alright, there. This one would be 270 degrees less than theta, less than 360 degrees. What will this one be? 180 when we have 270 degrees. And here what do we have? We have 90. This, we would need the information till grade 12. Okay, what did we come up with? Here, all trig ratios are positive. Only sine is positive. Tan is positive. And cos is positive. Going this way, there's so many acronyms. There's CAST. Alright, but that starts from quadrant 4. CAST, C-A-S-T. Alright, it's also said that all science teachers cheat. Whatever, there's so many funny acronyms there. All science teachers cheat. So many kind of, or all students, you know, all students take Coke. Alright, Coke as in Coca-Cola. Alright, that's another one. All students take cola. So whichever way, the main thing you need to remember is that in the first quadrant, where my angle is there, okay, in the first quadrant, all are positive. In the second, only sine is positive. In the third, only cos is positive. And in the fourth, or in the third, only tan is positive. And in the fourth, only cos is positive. This is a very, very lovely video. You need to go over this video. It's quite a bit lengthy. So we've dealt with all our special angles and all of that. In the next video, we'll do it a few activities and check some other reciprocals of trig ratios. I hope you enjoyed it. Thumbs up from my side and good luck.